Okay, hi. First of all, this is an IPython notebook, just in case you haven't seen that plugged enough. Thanks to the Rise package, which lets it be a reveal slideshow. It is also a slideshow. However, I hope it's not messed up like that. Well, we'll see for a minute. I'm Catherine Devlin. There we go. That's more like it. I'm going to tweet out the URL of this. So, relational databases. You can have my PostgreSQL when you pry it from my cold, dead fingers. And of course, SQLAlchemy is a great tool for this that you probably think of as an object relational mapper, which yes, technically it is, but honestly, I consider it a general purpose toolbox for working with relational databases that lets you build tools that work across databases, so even for those poor folks who aren't using Postgres, your tools can help them. And I'm going to show you 3 examples to get you inspired to work on your own tools. So, a lot of data out there is not in a relational database yet. Like for instance, I've got some data here that's in a YAML file. That's nice. With DDL generator, I can actually examine that YAML file, generate the SQL that would be needed to define those tables, and then if I like, generate the inserts also. There's a lot of tools that will go to data, but I don't know of any others that will actually examine it and figure out what table definitions you need. And so, as a result, nothing up my sleeve, empty database, I can actually fill, here's a one-liner that examined that YAML file, piped it into PSQL, and populated a database. Oh, and also, if you notice, this was a hierarchical. So I had a child table, parent table, foreign keys all defined. But I claim that it's in the database, so now I've got to prove it to you. There's a lot of SQL clients out there, some really awesome ones. But there's a SQLAlchemy-based extension that lets you use SQL against, that lets you use it within the IPython notebook. So I'm making my connection, and then I'm running SQL, and I get a nice, pretty IPython type result. It can be more complex SQL, so that any arbitrary SQL you can use here. And, oh, did I not show? Hang on a second. Oh, well, see if this is going to work. All right. You can assign the results into Python objects. It actually contains a data frame method, which spits out a pandas data frame for you. And then, of course, you can do all the wonderful pandas stuff you saw from the last talk. So nice integration there. Where did you go? All right. All right, you've got data, it's in your database, you can work with it, but you only want some of it to test with. And the trouble is that trying to get a test database that really represents the production data can be like trying to snip a little bitty sweater out of a big sweater and not break any threads. The relational, all the relationships you need to respect. So wrote up a little package that actually can generate that for you pretty simply. Here I am setting up, what am I doing here? OK, oh yes, creating an empty database with the same structure. So basically, I've got 2 databases now, one with my production data, one that's ready to receive the test data, but all the tables are empty. And I'm using subsetter to say, OK, grab that production data, take 1/10 of it, and insert it into the test database. And it's not just 1/10 of the data at random, it's roughly 1/10 of the data with all the relational integrity respected. And so there's just an example. This is running against the test database. All right, 3 example tools. Here are some vaporware from my head. I pretty much know how these can be implemented with SQLAlchemy, but I don't have time to do them all, so hopefully some of you will be inspired. I'll talk to you about them. There's a lot of amazing possibilities. So yes, I will tweet the slides shortly. Thank you.
All right, I'm Floehr, and I didn't bring my laptop, so this is on Catherine's. Thank you so much. And I can't give you the full treatment, but I have a time-lapse camera that I set up using Raspberry Pi and just a Canon point-and-shoot camera pointed out my window at the sky. It's been taking a picture every 10 seconds for about 2 years now, and I'm on camera number 3 because they tend to wear out after that many photos. I now have over 5 million images, and I just passed 4 terabytes. I can't fit it on a 4 terabyte drive anymore. So I bought a 6 terabyte drive. That'll last another year. So hopefully they'll have 12 terabyte drives at that point. So I've done some pretty funky things with it. I've looked for faces in the clouds using PyOpenCV. I've captured lightning, which is kind of incredible. It just takes a picture every 10 seconds, so it has to be really lucky. And I've done some kind of really odd visualizations, like this one right here. Like this is actually going through time that way. So I've been doing some weird stuff. So there's night coming and sucking the black hole, and then there's day again, and then night. So I've been doing some really weird stuff. So I'd actually be really interested in your feedback at any point what I should do with it. It's a lot of data. Data can be fun. And I have a lot of it. So I'm planning to give, I submitted a talk proposal to PyOhio. If it's accepted, you'll get to hear more about what I've done and how I've done it. I've used gphoto 2 to capture the images, and I've used a lot of Python, Pillow, Django. I actually use Django just for the ORM. Sorry, SQLAlchemy, but so I have a database with all the images and all that. So another thing I've been doing is, we've all heard about data visualization. And again, sorry, my GitHub repo, this is constantly in progress, but if you want to see the code that I've used to both analyze and capture the images, it's github/efloehr, EFLOEHR/timelapse. But then we've all heard about data visualization. I've been playing around with data sonification. And data sonification is basically visualizing data in sound or something like that, or listening to data in sound. And I also have this. Did you know in Python there's a built-in library that allows you to create WAV files, .wav, which is the same format that every CD that you ever bought uses, right? It's WAV format. And within Python, without downloading any external libraries, you can create WAV files. So I have some examples here in my sonification library. This is just stuff me learning how to do it, including generating sine waves, which is really notes, right? And then I use a Python library called Pygnon, which allows you to write MIDI files. So I've done a few things with it, but and if you go to SoundCloud / I don't remember what the thing is, but if you search on my name, you'll find it. And this right here is, I don't know if you're going to pick, yeah, you're not going to be able to pick it up. But anyway, if you go here, I actually took the size of the time-lapse files, the images, because at night they're lower because they can compress really well, and at daytime they're not. And you can actually hear patterns in it. You can actually hear when the camera goes bad because for whatever reason, the reason the CCD went bad, it actually created large files. So you got all kinds of cool stuff. So anyway, I also then used the MIDI library to take temperatures in Columbus for March 2014 and mapped it to piano notes. And we'll see if we can get this. I don't know. But you might be able to hear that a little bit. So if you have any ideas for data sonification, or if it inspires you, let me know. I'd love to talk to you about it. I'd love to talk to you about time-lapse, sonification, anything like that. So my email is eric@intellivations.com. And thank you so much.
Hi, my name is David Blewett. I work for a computer security company called CrowdStrike. Our main product is a sensor that sits in the kernel of Linux, OS X, Windows. Sends all the events of whenever there's network connection, process started, process ended, things like that. But so that stream generates a lot of data. We use PyPy as an analysis engine for looking at that, looking for anything that we might think is malicious. But the interesting thing about how PyPy works is that it's an alternative Python interpreter, so it's not based on CPython. It's actually Python, your code running on a Python, restricted Python interpreter. So that being said, it gets some of its advantages. The regular C Python doesn't have any real insight into your code if this is a string or this is an integer, how to optimize different ways that your program accesses data. But PyPy does some pretty amazing just-in-time compilation. So as your program is running, it can figure out what you're trying to do, see the patterns and how you're accessing different spaces of data so that it can optimize that and make your program run faster. So this real-time stream of data that we get, the distribution of all the different events doesn't change a whole lot over time. So as that stream is coming through, if I restart one of the PyPy workers, we might start at around 10,000 events per second, but as the just-in-time compiler warms up, it jumps to usually about 30,000 events per second. So we get almost a threefold increase in performance, and that comes at no code cost to me. The compiler does it all. My code doesn't do anything special to take advantage of that. There are some restrictions to using PyPy, like some of the C Python extensions don't play as nice under the PyPy framework. They have what's called a CFFI, for Foreign Function Interface. There are a lot of packages that can take advantage of that if you are using C for performance enhancement. The CFFI can speed that up a lot, but a lot of the time, what you need to do can just work on PyPy. So if you were doing a lot of number crunching or things that run for extended periods of time, you should give PyPy a shot. You can get a pretty decent performance increase with not a lot of cost.
So Nodebox is, I guess it was a JavaScript library that was based on processing. So it's like this JDL that lets you do art type things, or was designed to, and then Nodebox came along and had a JavaScript library for it, and then they made Nodebox OpenGL, so there's a Python library for it. And since I do a lot of report automation, my clients need like custom visualizations that our designers insist that we have to have, so I can make them myself now, or recreate the magic that they want. And so for IndiePy, I threw this together this morning, actually. You can see that I've tried to recreate your logo, guys. I was way too lazy to do the little flame thing, but there's basically a bunch of layers stuck together. You can see where this draw function runs constantly at 30 frames a second. You can set that. The blue circle, the yellow circle, blue circle, it's kind of a lazy way to do it. There's the path of the text, which is sort of defined above. I'm kind of flying through this. All your stars, I know it's redundant. I could make a programmatic way to do it, but I was in a hurry. And our end results right there with pretty simple code of just like put this square here, make a star. I've done some other cooler things like animations that uses its built-in canvas function. I have a LED dance floor at home that I built with friends in college. So I can visualize all sorts of wacky things going on. That's awesome. Yeah, so like, what I love about this is this actually like displays on my floor at live on this. So we have great parties at my house if you want to come down to Nashville. But more importantly for you data science folks is like visualizations for clients, right? So you can easily define any color that you're interested in and have some globals, which is probably a bad idea, helper functions. And since you're layering different types of images that you need to use over and over again, you can create a class that inherits the Nodebox layer object and kind of stick them all together. And I made a scale for a metric that the proprietary metric they have. So I can set like this month and last month, and it dynamically puts these markers there, right? So I don't have to have last month say like you know, I can only have 1 month, and that can be 350, and it just moves. And that saves to a file, and since I'm making PDFs, it's real easy to just pick that up, throw it in there. But if you have any questions about magical things you can do with Nodebox OpenGL, let me know. Nodebox 3 came out, which provides a like drag and drop interface with like, you can just drag a square onto this like connected network of stuff, and that makes your visualization. That was way too like hand wavy for me. I much prefer this. So yeah, that's custom visualizations.
So this is Unicode, or why do I see that instead of a quote mark? Probably all seen that before. That's a, well, we'll kind of go over why you see that. So first of all, I guess, okay, well, let's talk about Unicode a little bit, what it's itself, right? So we all know that in the computer, everything is stored as ones and zeros and numbers. And when we run represent text, you know, like sentences and stuff like that, there's different ways you can do that. ASCII is a common code, right? And so each possible value is assigned a numeric value, which happen to range between 0 and 127 or 255 if you consider that part of ASCII or not. But you take those values, that's 1 byte, right? So each byte in your data file represents one of those characters, and you know, it's a one-to-one translation. It's like if it's the byte code is 32, I think that's a space. You know, if it's something else, it's something else. Now the problem, of course, with that was with using 1 byte. Let's go to the next slide. Is that you're limited, right? So the whole idea behind Unicode is we're going to have a much larger address space, so we can cover every possible character, across anything. So we have what's called code points in Unicode. So these are 3 simple examples of characters that you can encode in Unicode, what their corresponding code point is. The lower, like standard ASCII, this one here, the $sign there from standard ASCII has the same value in Unicode as it does in ASCII, and that's on purpose, just to make things easier. But you can have a lot more, like this one at the top is a point of interest symbol. You got another symbol there. And so you got their code points in hexadecimal, and then I'm showing you the binary representation because we're going to talk about that in a second. Originally, we had a full 31 bits. There's only 21 bits available for every possible Unicode code point, right? And not all those have even been assigned. I think we're only up to like the 17th power, and you know, so we could like double the entire set of characters that we currently have in the Unicode 2, 4, 8 more times. So we're not running out of space, and so it's nice. You have this one consistent thing. So the code point, though, is separate from how you actually save that in a file, right? You could, in 32-bit encoding, UTF-32-bit is a 32-bit encoding of Unicode code points in which you just literally write all 32 bits. The problem with that is if you're dealing with mostly ASCII data where you're only really using, you know, the lower 8 bits or 1 byte, so you're going to have lots of these zeros, your file's going to be big, and it's not efficient. So what I'm talking about is UTF-8, which is an 8-bit variable width encoding. And so how does it work? So basically, depending on the Unicode code point that you have, you look at the number of bits in that code point, and then you're going to get a certain number of bytes. So if it's 7 bits or less, in other words, if you have the standard ASCII, it encodes just as a single byte, just like it would in ASCII, and that's on purpose, right? And technically an ASCII file using only lower 127 characters is also a UTF-8 encoded file, and it will have should have the same meaning and everything. But as soon as you get up into those higher Unicode code points where the code point itself takes 3 or 4 bytes, or not actually, no, they can only go up to 2 bytes. So it takes 3 or 4 nibbles, right? Then, maybe I'm saying that wrong. Anyways, whatever. They get bigger. You have these patterns here. And so one code point all of a sudden can actually take up 3 bytes. And the way you do that, for example, if you look at the third line there, 16, so your first byte would be 1110. That's kind of like an indicator that, there's 2 more bytes that are coming that are part of this. Then you fill in the actual first 4 bits of your code point, the high order bits. Then the next 2 bytes all start with 10, which is a continuation marker, which says I'm continuing on. Actually, this is part of the previous thing. And basically, if you fill in your code point bits into those X's, then you get the value. So here's an example. That UTF-318, there's like what it looks like, okay, and I've color coded it for you. This is the second line is the encoding you're going to use. It's going to take 3 bytes, and so if you follow the colors, I've kind of filled in those X's where those go, and the resulting is 3 bytes that are E28C98, which happen to, if you interpret that incorrectly, not as Unicode, but as straight ASCII, turns out to these 3 random weird characters, so instead of that, you get that. And that's what's happening sometimes. Somehow something crossed systems, it was encoded in Unicode in one place and it was read as straight ASCII in another under some code page, and you got that crazy stuff there.